She's a Mona Lisa. Everyone's lining up to see her.
For the reaction of ferric chloride using acetic acid and benzoic acid, you will need the following materials: test tubes, droppers, litmus paper, Bunsen burner, ferric chloride, ammonium hydroxide, acetic acid, and benzoic acid. The procedure itself: first, you must prepare a neutral ferric chloride solution by adding ammonium hydroxide dropwise to ferric chloride until a faint but permanent reddish precipitate forms. Next, dissolve acetic acid and benzoic acid in water or ethanol if it's insoluble to water in separate test tubes. Next, add ammonium hydroxide dropwise until it is alkaline in litmus paper. Then, gently boil until the smell of ammonia is no longer present. Lastly, cool the solution and add the ferric chloride solution. Observe any change in color or formation of precipitate. This test is done to detect carboxylic acid presence. In acetic acid, a red wine color will persist, which indicates positive results, while in benzoic acid, there will be colored precipitate at the right pH level.
Esterification of acetic acid. For this experiment, you will need 1 test tube, 3 droppers, 1 graduated cylinder, and 1 500 milliliter beaker. For the reagents, you will need ethanol, glacial acetic acid, sulfuric acid, boiling chips, and distilled water. Procedure. The first step is to put 1.5 milliliter of ethanol into a test tube. Then, using a separate dropper, add 2 milliliters of glacial acetic acid. For the last addition, using another separate dropper, we have our catalyst, which is 1 drop of sulfuric acid. For safety measures, you are advised to add boiling chips into the mixture to provide bubbles a surface to bounce off on instead of the glass, preventing it from cracking. Once the mixture is done, we can now put it in a beaker, filled halfway with water for a boiling water bath for 4.5 minutes. After heating, cool it down first. Before carefully smelling the odor, wafting gently, it should change from a strong vinegar smell to a sweeter, fruity aroma, indicating the formation of ethyl acetate. Explanation. The objective of this experiment is to produce ethyl acetate, an ester with a sweet and fruity smell, by the esterification reaction of ethanol and glacial acetic acid catalyzed by sulfuric acid with heating in boiling water. Mixing the reactant with the catalyst starts the reaction, while boiling chips provide secure and controlled heat. Following the reaction period and subsequent cooling, the most significant observation is the alteration of smell from the sharp vinegar smell of acetic acid to the fruity, pleasant smell of the freshly produced ethyl acetate, a simple qualitative indication of the successful chemical reaction.
For the sodium bicarbonate test using acetic acid, you will be needing test tubes, dropper, sodium bicarbonate, water, and acetic acid. For the procedure, first, prepare a saturated solution of sodium bicarbonate by dissolving sodium bicarbonate in water. Second, add the acetic acid to the saturated solution of sodium bicarbonate. Third, shake the solution well. And lastly, the formation of bubbles should be visible since carbon dioxide is emitted from the reaction between acetic acid and sodium bicarbonate. Furthermore, slight cloudiness can also be observed due to the formation of bubbles.
For reducing property of some carboxylic acids, materials and chemicals used are sodium borohydride, a non-aldehyde or ketone, 95% ethanol, deionized water, methylene chloride, magnesium sulfate. For the equipment, microwave reaction vessel, stir bar, temperature probe, microwave reactor, separatory funnel, and rotary evaporator. For the procedure, reaction mixture is the first. Combine sodium borohydride, ethanol, and unknown aldehyde or ketone in the reaction vessel with a stir bar. Next, heat the mixture in a microwave reactor, monitoring the temperature with a probe until the reaction is complete. Next, transfer the mixture to a separatory funnel, dilute the water, and extract with methylene chloride twice, combining the organic layers. Wash the organic layer with the ionized water 4 times. Dry the organic layer with magnesium sulfate. Filter the solution into a round bottom flask. And lastly, evaporate the solvent using a rotary evaporator to isolate the product. The reaction successfully reduced the unknown aldehyde or ketone to its corresponding alcohol. This is evidenced by the isolation of a product after the reaction, extraction, and purification steps. Sodium borohydride is a reducing agent that selectively reduces aldehydes and ketones to alcohols. The hydride ion from the sodium borohydride attacks the electrophilic carbonyl carbon of the aldehyde or ketone. This breaks the pi bond and forms a new CH bond, while the oxygen atom is protonated by the solvent, ethanol, or water to form a hydroxyl group. The overall process converts the carbonyl group into an alcohol, effectively reducing the starting material. This reaction is favored due to the relative stability of the resulting alcohol and the driving force provided by the hydride transfer.
She's a Mona Lisa. Everyone's lining up to see her. She's a Mona Lisa.